Hello friends, myself Professor Joshi VM from ADSUL'S Technical Campus, Chas, Ahmednagar. Today we solve problems or numericals of transformer chapter. Uh, after you listening total whole lecture, you can easily understand how to solve the numericals of transformer chapter. Okay, so let us start the numerical. A 55 kVA single phase transformer has primary winding of 460 turns and secondary winding of 160 turns. The input side of transformer is supplied with voltage of 2500 volt and 50 Hz frequency supply. So calculate secondary voltage, primary current I1, primary secondary current I2 and max value of the flux. So let us start the numerical solving. Okay, the solution to the above problem can be calculated as follows. First of all, we have to write a given data, and the given data is kVA rating is given. kVA rating is 55 kVA. After that, N1 is given. N1 is given 460 turns, whereas N2 is given 160 turns. After that, V1 is given 2500 volt, and last is frequency is 50 hertz. Frequency is given 50 hertz. Okay, this data is given. kVA rating 55 kVA, N1 460 turns, N2 160 turns, V1 2500 volt, and F equals to 50 hertz. Okay, first step we have to calculate transformer voltage and turns ratio. So we use here transformer ratio, transformer voltage and turns ratio to calculate the primary and secondary current. So from transformer ratio, ratio, that is voltage and turns ratio, V2 upon V1 equals to N2 upon N1. Okay, we can rearrange this ratio. We can get V2 upon 2500 upon 160 upon 460. We put here the values of V1, N2 and N1. Okay, so we get V2 equals to 160 into 2500 upon 460. 00 get cancelled, and after solving this we can get V2 equals to, by solving this we can get V2 equals to 869.56 volt. So we get here V2. By using this V2, we have to calculate the V1 or primary current, full primary current. Okay, to calculate primary full load current, we use the formula I1 full load equals to kVA into 10 raised to minus 3 upon V1, putting the values 55 into 10 raised to 3 upon 2500, we will get 22 ampere. Okay, 22 ampere. This is a full load primary current. So now we calculate the secondary full load current. Secondary full load current. To calculate the secondary full load current, we have to use same formula. Instead of I2, we have to write right here I1, we have to write here I2, and instead of the V1, we can write here V2. Then the formula becomes kVA into 10 raised to 3 upon V2 equals to 55 into 10 raised to 3 upon 869.56. We calculate here V2 voltage. Okay, we have to use this V2 voltage here, and by solving this equation we will get 63.25 ampere. Okay, this is the I2 full load current. So we calculate here first I1 full load current, after that I2 full load current. After that we have to calculate the maximum value of flux. Then third, maximum value of flux, that is phi m. So we know that the formula of induced EMF, we have to use this formula, that is E1 equals to 4.44 F N1 phi m, and we know that the formula E1 equals to 4.44 F N1 phi m, and we know V1 equals to E1. Because of that, we can write here V1 equals to 4.44 F N1 phi m volt. After putting all the values, we will get 2500 equals to 4.44 into 50 into 460 into 5. So we can rearrange this equation. We will get phi m equals to 2500 upon 4.44 into 50 into 460, and by 0 get cancelled, this 0 get cancelled, and by solving this we will get the value of phi m is 0.0245 Weber. Okay, we calculate I1, I2 and required maximum value of the flux. So let's take second numerical, that is numerical. I read here numerical. A 5 kVA single phase transformer having turns ratio of 8:2 connected to the supply voltage of 3500 volt. So determine the value of secondary resistance and primary current. Okay, so the solution to the above problem can be calculated as follows. So the given data is, first of all we write here given data, and the given data is KVA rating equals to 5 kVA and N1 equals to 8 and N2 equals to 2, because the ratio is given and it is to 2, and V1 is given 3500 volt. So this is given data is given to us. By using this given data, we have to calculate or determine the value of secondary resistance and primary current. Okay, but so to calculate this, first of all we use transformer voltage and turns ratio. The voltage and turns ratio, we know that the voltage and turns ratio is V2 upon V1 equals to N2 upon N1. Hence, we put here values, we will get V2 equals to V1 N2 upon N1. So put here the values, then V2 equals to 3500 into N2 is 2 and N1 is 8, and by solving this we will get V2 is 875 volt. Okay, so after that the secondary full load current, previous numerical we know this formula, so here we also use this formula. V2FL equal I2FL equals to kVA into 10 raised to 3 divided by V2. So put the values of kVA 5 into 10 raised to 3 upon the value of V2 is 875. After solving this, we will get I2 equals to 5.714 ampere. This is our second answer. After that, we have to calculate load resistance. So the formula for the load resistance is R2 is equals to V2 upon I2 full load. We know that the V2 is 875 and I2 full load we calculate here and put this value here 5714. After the calculating or solving this by on calculator, we will get 153.13 ohm. Okay, from the current and turns ratio, I1 upon I2 equals to N2 upon N1. Hence I1 equals to I2 into N2 upon N1. Therefore, I1 equals to, by putting the all values, 5.714 into 2 divided by 8, I1 equals to 1.43 ampere. This is the value of I1. So here we calculate by using voltage and turns ratio. We calculate here value of V2, that is 475 volt. After that, we calculate the secondary full load current by using I2FL formula, and we will get the value of I2 is 5.7 4 ampere. Then we calculate the value of R2 by using V2 upon I2 FL, and the value of I2 is 153.13, and finally we'll calculate the value of I1, and we will get the value of I1 is 1.43 ampere. Okay, thank you. We will briefly explain next numerical in next lecture. Thank you.